Second segment is performing routine maintenance. This is after it's been in service, and you need to periodically check things. Mechanical driven equipment, uses oil, gets wear and tear, so you want to make sure you do certain checks. As previously shown in previous class about the packing replacement, it all applies where it's a vertical turbine pump or a centrifugal pump. This particular one has a mechanical seal, so there's really not too much adjustment on the mechanical seal once you get everything else adjusted for setting. But like I just showed previously, this particular pump has a open type impeller, which there's no shroud on it, no wear ring, and you've got different kinds of centrifugals that has different kinds of adjustment. This particular one has lockdown bolts and jacking screws on the bearing housing. Which enables you to move it in and out to close up the clearance from the impeller to the inside of the blue casing. As previously said, this particular pump has a mechanical seal. You want to check to make sure it's got the proper adjustment. There usually is instructions with each seal. You have to actually install it or do adjustment on it that tells you how to get the setting once you have done your other adjustments. Inspect that, make sure that's correct. Some pumps are shipped with a spacer or a shipping fork, and those have to be removed and maybe final lockdown after everything's in place. But as previous before, you documented when you did the initial installation, check the amperages, the voltage, the pressure output, and the flow, and see if you've got everything you need as compared or trending, how it compared to what you was when you first installed it. You care to talk about this, Charlie, on the lubrication and so forth?
On lubricating your bearings, you got oil or you got grease. One thing is you don't want to mix the oils or mix the grease. Make sure you're using the same type. As far as greasing a bearing, it's based on the hours that you run it and the operating condition and the speed of it. So you need to go back to the owner's manual and always refer to it for your specific needs on it. You always want to look at every time you inspect it. It's a yearly inspection or whatever. Make sure you don't see any deterioration on the base. It's going to cause any issues or a lot of rust build up on it. If it is, you need to treat that, because if you don't deal with it, it will just get worse and cause problems. Make sure before you take the guard off or do any mechanical stuff, it's locked out, tagged out. Once you've done that, we want to pull the guard off of it. We can check for alignment and everything to see if we're still lined up. We can make sure nothing's come loose. Bolts, screws, nuts, they all can work themselves loose. So we want to check all that stuff, make sure everything is tight and everything's working the way it's supposed to. Put our guard back on and bolt it down. After we got everything hooked up, we got our valves turned back on, our water's on. We'll have a qualified electrician energize it and run it. If we haven't unhooked anything other than locking it out, our rotation should still be the same. When we start up, we want to again check the amps, the volts, pressure on the gauge. If you've got a gauge, if you've got a flow meter, do it, record every bit of it, and take it back compared to your initial startup. Then you can see if you're losing any performance, and if you are, you might need to go back up here and readjust the pump. On an open impeller, if it's a closed impeller, you might have to pull it and actually get it sent off to the repair shop to get it rebuilt.
We'll step over here. We've got a couple more examples I want to show you about different styles of impellers and adjustments. Like I said before, we've got different types of impellers. You'll see different impellers on whatever the application may be. This particular one is a trash pump. It's an open vaned trash pump that uses a wear plate on the front, and this particular one is a self primer. That, from the looks of it, it's got a check valve on the suction side that helps keep the cavity full of water when you're first initially priming it. And it has, looks like a cutwater area where the impeller comes in close to it to help evacuate the air out of the system. A particular adjustment on this one, there's a wear plate here that can be shimmed and then locked down in place. Some of these, they may have shims in behind the impeller, because over time this front area will wear this wear plate. You want to close that gap back up. This particular unit looks like it's an oil-filled unit, which on the, like with the other pump, it's best to have a site level oiler, that way you can actually visually see it. There's a breather up here for expansion of heat. We'll step over and see this other one here. See the third example. So, this is another example style of pump. This is a enclosed impeller trash type pump. It may only go up to maybe like 1 inch solids at the most. So it can hit a lot of different areas of the application that you may be using. This particular one has no adjustment on the bearing frame or the impeller. What determines the clearance is the wear rings of the impeller to the ID of the wear ring side of the pump casing. Rough rule of thumb, it's going to be somewhere around 15 thousandths, plus or minus, depending on what size it is, what application it is, and what temperature the water is. If you've taken one off, take the blue housing off, these are balancing where they've actually had to balance the impeller. So it's not wear spots, it's where they take weight off of it, dynamically balance the impeller to get everything running smoothly. This particular pump, the lubrication is grease lubrication on the front bearing and the back bearing. There's these Zerk fittings that have these little plastic protective caps usually, but it's a grease fitting that you can apply grease by the recommended lubrication specs in the IOM manual. You got to make sure you got compatible grease and use it. You don't want to use different base grease that's not compatible with each other. But there's one on the front, one on the back, and you've got to not over grease the bearings because it will cause premature failure. They have to have room to breathe. The rule of thumb is no more than 2/3 capacity of bearing of grease. But you definitely don't want to fill this whole cavity up. That would be a detrimental to pump failure real quick. As within a motor, you never want to over grease them. So too much grease can be worse than not enough.